So, what if scientific discovery didn't depend on a researcher pulling an all-nighter in the lab? What if, instead, an AI could run hundreds of experiments for you while you sleep, getting just a little bit smarter every 5 minutes? Well, this isn't some far-off sci-fi dream. It's actually happening right now. And believe me, it's about to change everything. Take a look at this. It's a fictional note that Andrej Karpathy, one of the top minds in AI, tucked into a recent project. He wrote it from the perspective of the near future, looking back at us, at meat computers. And here's the kicker. In that very same project, he gave us the tools to start building that exact future today. So, let's jump from that sci-fi prologue into the real world. Let me introduce you to a project called Autoresearch. This isn't just another piece of code. It's a signal of a massive shift in how we think about machine learning and, honestly, maybe all of science. At its core, Autoresearch is exactly what this says. It's a tiny, self-contained research lab. It's this minimal, almost elegant system that Karpathy calls an unconstrained engine of discovery, and it just chugs along, all on a single graphics card. So what is it, really? Okay, you basically give an AI agent access to a real training environment for a large language model. Then you just let it go. The agent starts messing with the code, running its own experiments, and just relentlessly tries to make the model better, over and over and over, with basically zero human help. And the real genius of this whole thing is just how simple it is. This isn't some bloated, complicated software. It's actually a shockingly simple and clean setup. So let's pop the hood and see how this little lab in a box actually works. Okay, so check this out. The entire system, and I mean the whole thing, is run by just these 3 files. The human's only real job is to edit program.md. That's just a text file with your high-level ideas. The AI agent, its job is to constantly rewrite the Python code in train.py. And that last file is for data prep. It's locked down, never touched. That's it. Simple, right? And this is where the magic happens. This is the engine of discovery. The AI gets an idea, maybe it tweaks the neural network a little, it rewrites the code and starts a training run. But here's the key. It only runs for 5 minutes. Then it checks one single number, the validation loss, which is basically the model's error rate. Did the error rate go down? Yes? Great, keep the change. No? Junk it and try something else. And it just does this again and again all night long. So how many times can it do that? Well, on just one GPU, Autoresearch can run about 100 different experiments overnight. 100! A human grad student would be lucky to get 1, maybe 2 experiments done in a whole day. We're talking about a totally different scale of research here. But this Autoresearch project didn't just appear out of thin air. It's actually the latest chapter in a story that's been unfolding really, really fast. The real hero of the story is the idea of the loop itself. Putting an AI in a simple, repeating cycle with a very clear way to tell if it's winning. I mean, just look at this timeline. The pace is just insane. In about a year, we went from vague ideas like vibe coding to the Ralph Wiggum technique, which proved that even a simple AI in a dumb loop could do amazing things, all the way to these sophisticated agent factories and now autonomous research. With every step, the human gets pushed further out of the loop. In this comparison just makes the pattern so clear. The Ralph Wiggum technique used that loop to make software better by just checking if the code passed its tests. It showed us that just trying over and over is its own kind of intelligence. Autoresearch? It's the exact same pattern, just aimed at a different target. Machine learning research, where winning means making the model perform better. Same loop, different game. So, you have to be wondering, what does the output from this new kind of science actually look like? Well, we have this incredible example, a full scientific paper written entirely by an AI system. It feels like a report that was sent back in time from the future. And here it is. Just look at that warning right at the top. It's kind of chilling, but also incredibly exciting, isn't it? This is not a fake. It's a real artifact from this new world of automated science. It's a genuine sneak peek at what's coming. But here's the catch. Just because an AI can write a paper doesn't mean it's a good scientist, at least not yet. When you really dig into this paper and what human reviewers said about it, you get this super clear picture of both the amazing potential and its current, very rookie-like flaws. For instance, get this. The AI writes a section on related work that sounds totally convincing, but then a human expert reads it and points out that one of the big citations doesn't really belong there. It's like the AI has memorized a bunch of phrases but doesn't truly understand the grammar. It knows what things are supposed to look like on the surface, but it's missing that deep, intuitive understanding a real expert has. And this part is just fascinating. You've got one reviewer totally trashing the paper, calling the experiments unmotivated and the conclusions misleading, but then another reviewer praises it for being novel and well-structured. So what's going on? Well, the AI is clearly good at coming up with new ideas, but it's pretty bad at doing rigorous science and explaining why it did what it did. So here's the bottom line, the takeaway from all this. The AI scientist, right now, is like a super promising student. It's great at exploring new ideas, it knows how to follow the rules and structure a paper the right way, but it's also like a first-year grad student. It misses crucial context, it misreads its own results, and its experiments are frankly a little sloppy. Okay, so this all leads us to the biggest, most important question of all. If AI agents are going to be the ones doing all the hands-on experiments, what's left for the human researcher to do? In this new world, you're not the one down in the trenches writing every single line of Python. Your job is to be the conductor. You're the one who defines the high-level strategy, the creative direction, the big-picture goals. You become the architect of the whole experiment. And this quote from Gary Tan just hits the nail on the head. For decades, the thing holding back research was not having enough expensive computer power. But pretty soon, the main bottleneck is going to be the quality of your ideas, the creativity that you pour into that one little text file, that program.md that tells the AI what to do. So, what does this all mean for you? It means the skills that matter are changing. The ability to ask the right questions, to design a good scientific playground for the AI, and to dream up an inspiring research plan, that's the new frontier. Your insight is what's going to unlock the power of these autonomous agents. And I really want to leave you with this final thought. We've been talking about using this AI engine to improve, well, AI. But what happens when we point this relentless, tireless engine of discovery at our other huge challenges? Finding new medicines, designing better solar panels, creating brand new materials, all being worked on 5 minutes at a time while we sleep. That is the real promise of the autonomous scientist, and the future it's building looks pretty incredible.